You are standing on a rocky coastline 220 million years ago. The air is thick, warm, and smells of salt and ancient conifers. The waves of a vast primordial ocean crash against the shore, but the sky above you is strangely silent. There are no gulls, no eagles, no birds of any kind. Instead, you see a shadow pass overhead, impossibly fast. It's not a bird, it's a reptile. Its wings made not of feathers, but of a taut, leathery membrane stretched across its body. It dives, plucks a fish from the surf with a snap of its needle-toothed jaws, and soars away with a powerful beat of those skin-thin wings. Ever wonder what it truly felt like to see a sky that belonged not to birds, but to dragons? Let us know in the comments where you're watching from, and which prehistoric creature captures your imagination the most. Now, let's journey back in time and uncover the story of a lost world. This creature you just witnessed is a pterosaur, and it represents one of the most magnificent and misunderstood lineages in Earth's history. For over a century and a half, these animals have been mistakenly called flying dinosaurs. It's an easy mistake to make. They were reptiles. They lived during the Mesozoic era, and they were certainly as awe-inspiring as any Tyrannosaurus or Triceratops. But they were not dinosaurs. They belonged to a completely separate parallel branch of the reptile family tree. While dinosaurs were mastering the land, the pterosaurs were achieving something no vertebrate had ever done before. They were conquering the sky. Their story begins not with a grand skeleton, but with a puzzle. When the first pterosaur fossil was formally described in the late 1700s, it baffled the greatest minds of the time. Scientists saw a reptile with an absurdly elongated fourth finger, longer than the rest of its body. What was it for? Some argued it was an aquatic animal, using the long digit to paddle. Others imagined it as a type of bat-like creature, dangling from trees. The name it was eventually given, Pterodactylus, from the Greek, for wing finger, was a hint, but the reality was still hard to grasp. How could a reptile fly? It was a biological contradiction, a creature that seemed to defy the known rules of nature. This was the dawn of a new understanding, the first glimpse into an age where reptiles didn't just walk, crawl, or swim. They soared. The answer to how a reptile could fly lies not in magic, but in a breathtaking feat of evolutionary engineering. As you examine the fossilized skeleton of one of these creatures, your attention is drawn to the hand. 3 of its fingers are slender, clawed, and seem perfectly functional for gripping a cliff face or holding prey. But it's the 4th finger that defies belief. This single digit, the equivalent of your ring finger, is stretched to an astonishing length, sometimes longer than the animal's entire torso. It is a biological spar, a lightweight but incredibly strong leading edge for the wing. This single, hyper-specialized bone is the key to the entire pterosaur body plan, the anatomical feature that gives the group its name and its mastery of the air. Stretching from this wing finger to the side of the body and ankle was the wing itself, a complex membrane called a patagium. Forget any simple idea of a kite made of skin. Fossil discoveries of soft tissue have revealed a marvel of biology. This membrane was layered, reinforced with a dense network of fine, stiff fibers called actinofibrils. These fibers acted like battens in a sail, preventing the wing from tearing and allowing the pterosaur to subtly adjust its shape for greater control, changing its camber and stiffness to manage lift and drag. It was a living, breathing airfoil, coursing with blood vessels, and controlled by tiny muscles. This wasn't the simple, leathery wing of movie monsters. It was a sophisticated, high-performance flight surface, utterly unique in the history of life. Of course, to get such an incredible structure off the ground, the rest of the body had to be equally specialized. Like the birds that would evolve millions of years later, pterosaurs developed bones that were almost completely hollow, filled with air sacs connected to the respiratory system. They were marvels of lightweight construction, reinforced with internal struts like the frame of an aircraft, providing maximum strength for minimal weight. Their torso was relatively short and stiff, creating a stable platform for the powerful flight muscles, which anchored to a deep, keeled breastbone. Everything about the pterosaur skeleton screams its dedication to an airborne existence. It is an anatomy of pure function, a body sculpted by the pressures of the sky into something both bizarre and beautiful. This masterfully engineered body was no short-lived evolutionary experiment. It was the foundation of a dynasty that would command the skies for an almost unimaginable length of time. Your journey through their world begins in the late Triassic period, around 220 million years ago. Here, the first pterosaurs are small, nimble creatures, many no larger than a modern seagull. You watch one, perhaps a Pterodactylus, dart through the humid air. It has a long, bony tail, tipped with a diamond-shaped vein of skin that acts like a rudder, providing stability as it hunts for insects. Its jaws are filled with sharp reptilian teeth. In this primordial world, the dinosaurs are just beginning their ascent on land, but in the air, the Pterosaurs are already pioneers, the undisputed rulers of a brand new ecological frontier. As you move forward into the Jurassic, the world transforms. The supercontinent of Pangaea is breaking apart, creating vast, shallow oceans teeming with marine life. This is the golden age for these early long-tailed pterosaurs, the Rhamphorhynchoids. You see a flock of Rhamphorhynchus at dusk, their dark wings silhouetted against a huge Jurassic moon as they skim the surface of a calm sea. Their forward-pointing, interlocking teeth perfect for snatching slippery fish and squid. But a new design is emerging. The first of the short-tailed pterosaurs, the pterodactyloids, appear. They are more advanced, with longer necks and more refined flight capabilities, representing a changing of the guard in the skies. The final act of their reign unfolds in the Cretaceous period. By now, all the long-tailed forms have vanished, completely replaced by their more sophisticated, short-tailed cousins. The world is warmer, and the skies are dominated by new and spectacular forms. You stand on the shore of the great inland sea that splits North America in two and watch a pteranodon glide effortlessly overhead. It is immense, with a wingspan like a small airplane and a dramatic crest sweeping back from its skull. This is the peak of the pterosaur dynasty. For 150 million years they have flown, adapted, and diversified, dominating the air through countless environmental changes. They witnessed the rise of giants like Stegosaurus and Brachiosaurus. And they were still soaring when Tyrannosaurus Rex walked the earth. Theirs is a story of incredible endurance, a testament to one of the most successful designs for a flying animal that has ever existed. This immense span of time gave evolution a vast canvas on which to paint, and the result was a spectacular radiation of forms. To speak of the pterodactyl is like speaking of the mammal. It misses the astonishing diversity. The name simply doesn't do justice to the sheer variety of creatures that took to the Mesozoic skies. In a lush Cretaceous forest, You might miss one entirely. You look closely at the bark of a tree as dusk falls, and what you thought was a piece of debris suddenly opens two large eyes. It's an Anuroognathus, a tiny pterosaur with a short, broad skull and a wide, frog-like mouth. It's covered in a dense, hair-like fuzz as it clings to the trunk, waiting. Then, it launches into the twilight, a silent, agile hunter of moths and beetles, the prehistoric equivalent of a bat. Now, travel to a salty lagoon in ancient South America. Wading through the shallows are dozens of pterosaurs that defy all expectation. This is Pterodaustro. Its upper jaw has small, peg-like teeth, but its lower jaw is a thing of wonder, containing over 1,000 long, fine, bristle-like teeth that form a perfect sieve. You watch as it lowers its bizarre jaw into the water, sweeping it back and forth, filtering out tiny crustaceans and algae just like a modern flamingo. It is a level of specialization that is utterly stunning, proof that pterosaurs evolved to fill highly specific niches. Over the open oceans, the more classic forms reigned. The great pteranodon, with its wingspan of over 20 feet, was a master glider, soaring for hundreds of miles from land, likely scooping fish from the water with its long, toothless beak. But the most awe-inspiring member of the dynasty wasn't a sea glider at all. You find it on the dry inland plains of late Cretaceous North America. At first, you don't even realize it can fly. Standing as tall as a giraffe is Quetzalcoatlus, the largest flying animal that ever lived. But you see it hunting on the ground. It stalks across the landscape on all fours, its massive wings neatly folded at its sides, its front limbs acting like powerful legs. Its neck is incredibly long and stiff, and it moves with a terrifying grace. It is a terrestrial stalker. You watch as it spots a juvenile dinosaur in the ferns. Its head darts down with the speed of a striking snake, and its massive, spear-like beak snaps its victim up. From a furry, bat-sized insect eater to a giraffe-sized terrestrial predator, the diversity of the pterosaurs was nothing short of magnificent. This incredible variety of lifestyles hints at something profound about pterosaur biology. The very act of powered flight is one of the most energetically expensive ways to live, an activity that requires a constant, roaring internal furnace. This was not the world of slow, cold-blooded reptiles basking in the sun to gain energy. To achieve what they did, pterosaurs needed a high, stable metabolism, much more like that of modern birds or mammals. For decades, this idea was a subject of intense debate, until fossils were unearthed that held the key. Under the right preservation conditions, you can see it, a soft, fuzzy halo around the animal's body. Pterosaurs were not covered in scales. They were covered in a dense, hair-like coat of filaments called pycnofibers. This discovery changes everything about how you picture them. These pycnofibers were a form of insulation, designed to trap the body heat generated by their active metabolism. It means you must imagine them not as leathery, naked dragons, but as fuzzy, active creatures, perfectly adapted for a high-energy life. This coat might have varied from the short, velvety fuzz on an Anuroognathus to a thicker, warmer shag on a species living in more temperate climates. They were warm-blooded rulers of the sky, a fact that makes them feel far more dynamic and alive. And it wasn't just their bodies that were spectacular. As you look across the different families, your eyes are inevitably drawn to their heads. Pterosaurs evolved the most elaborate and bizarre headgear in the entire animal kingdom. You see the huge, backward-sweeping crest of Pteranodon, a bony rudder, taller than its own skull. You marvel at the colossal sail-like soft tissue crest of Tupendactylus, a vibrant banner of skin stretched over delicate bone supports. Some had forward curving crests. Others had rounded knobs on their snouts. For a long time, their function was a mystery, but it's now clear these were not primarily for flight. They were for display. Much like the antlers of a stag or the tail of a peacock, these crests were billboards. They were used for species recognition, for intimidating rivals, and almost certainly for attracting mates. While we can only guess at the colors, it's easy to imagine these structures flushed with brilliant reds, yellows, and blues, turning the Mesozoic sky into a dazzling, competitive aerial pageant. These dynamic, warm-blooded creatures were masters of the air, but they were not chained to it. For a complete picture, you must see them in the other realms they inhabited, the land and the water. For over a century, scientists debated how a pterosaur moved on the ground. Did it waddle awkwardly like a bat? Or did it fold its wings up and walk bipedally on its hind legs? Fossil trackways, the petrified footprints of these animals, have provided a clear answer. You watch as a large pterosaur lands on a muddy riverbank. It doesn't stumble. With practiced ease, it folds its long wing fingers backward and plants its knuckles firmly on the ground, turning its wings into a pair of powerful front limbs. It was a quadruped, walking on all fours in a way that is utterly alien to us. This stance was not awkward. It was efficient, allowing even the giants like Quetzalcoatlus to move with surprising speed and agility, as you saw it stalking its prey on the plains. Their interaction with water was just as varied and specialized. You've seen the flamingo-like Pterodaustro wading in the shallows. Now you're back at the coast, watching a different hunting strategy. An ornithochirus glides low over the waves, its head down. The tip of its long jaw, which bears a distinctive rounded crest, slices through the water. This is skim feeding, a technique used by modern skimmer birds. When its beak makes contact with a fish, it snaps its jaws shut, tossing the meal into the air to swallow it whole without ever landing. Other pterosaurs were likely pursuit divers, plunging into the water from above to chase fish, much like modern gannets. They were not just masters of the sky, but masters of the interface between air, land, and sea, exploiting every available resource. Of course, for all their success, they were not without dangers. They were an integral part of the Mesozoic food web, and that meant they were also prey. A young pterosaur learning to fly would have been a tempting target for predatory dinosaurs like raptors, who could snatch them from a low-hanging branch. Out over the oceans, the danger came from below. A pteranodon gliding low over the waves might be ambushed by a giant mosasaur, whose powerful jaws could erupt from the water and pull the unsuspecting flyer to its doom. Even other larger pterosaurs might have hunted their smaller cousins. It was a dangerous world, and their 150 million year reign was a testament to their ability to navigate not just the skies, but a complex and perilous ecosystem. For 150 million years, the pterosaurs painted the skies with their incredible forms. But their world, for all its wonders, was not destined to last. Their dynasty continued right up to the very end of the Cretaceous period, 66 million years ago. You can imagine a Quetzalcoatlus stalking the plains of North America on the final day, unaware of the impending catastrophe from space. When the Chicxulub asteroid struck, the world was plunged into darkness and chaos. and the ecosystems that supported these magnificent flyers collapsed. The pterosaurs, alongside their non-avian dinosaur contemporaries on the ground, vanished from the Earth forever, leaving behind only their fossilized bones as a testament to their long and successful reign. For millions of years, that is all they were, a silent puzzle buried in the rock, waiting to be discovered. Their journey in our own understanding has been a long one, from the initial confusion over the first wing finger to the modern recognition of their incredible complexity. Today, their legacy is most visible in popular culture, where they are often cast as screeching, leathery movie monsters. But the reality you have witnessed is far more incredible than the fiction. The next time you see one on screen, remember the truth. Remember that they were not dinosaurs, but a unique and parallel success story. Remember that they were not naked, scaly beasts, but were likely covered in a soft, fuzzy coat of pycnofibers. Remember that the term pterodactyl refers to just one small member of a vast and varied family, more properly called the pterosaurs. And remember that for all their size, their hollow-boned construction made them lightweight masters of flight, not prehistoric cargo planes capable of carrying people away. Their true story is one of evolutionary triumph, of the first vertebrates to ever achieve powered flight, a feat that deserves our awe, not just our fear. And so our journey through the immense Mesozoic era, spent in the shadow of these magnificent wings, finally comes to its end. The world of the pterosaurs is gone, a lost kingdom that we can now only visit through the patient work of science and the power of our imagination. The next time you stand outside and look up at the sky, watching a bird trace a path across the clouds, take a moment to remember that you are seeing the inheritors of the world. But for a span of time that truly staggers the mind, that same sky belonged to an entirely different dynasty of flyers. It belonged to the warm-blooded, crested, and utterly spectacular reptiles that first dared to leave the land behind and conquer the air. It was the sky of the pterosaurs,